Welcome back to Talktv, where everything comes off the top. In today's review, we're going to be watching 10 scary yet beautiful facts about space and us.
Yeah.
You guys ready?
Let's do it.
Okay.
It's beautiful.
Yes.
Ten scary yet beautiful facts about space and us. Number 10. We are so small. Before we can truly grasp the gravity of the threats as well as the beauty that surrounds our planet, we must first realize just how small our planet is. The circumference of Earth at the equator is about 24,874 miles, and from the North Pole to the South Pole it is about 24,860 miles. Within our solar system, we are the fourth largest planet. After us, we are dwarfed by Neptune, Saturn, Jupiter, and our own star, which is 93 million miles away from us, the Sun. The Sun is a pretty big star, but it's nowhere near the sizes of other stars that we know about. To name just a few larger stars for perspective, there's Eta Carinae, a star that is over 5 million times larger than our Sun. Betelgeuse, 300 times larger than Eta Carinae. If it were our Sun, it would reach as far out as Jupiter. And then there's UY Scuti, the largest star that we know of. UY Scuti's mass is unknown, but before UY Scuti comes VY Canis Majoris, a star that is 5 billion times the size of our Sun. We are a part of the Milky Way galaxy. There are trillions of stars in our galaxy, and nearly all of them are circled by at least one planet. Within our Milky Way galaxy, we are not the only solar system. So far, astronomers have found more than 500 solar systems, and are discovering new ones every year. Scientists estimate that there may be tens of billions of solar systems in our galaxy alone. Traveling out 150,000 light years, you can see just how small even stars like UY Scuti is within our galaxy. It takes our Sun 200 million years to complete an orbit of the Milky Way, and 2.5 million light years away is the Andromeda galaxy, estimated to collide with our own galaxy in a few billion years. And using the Hubble Deep Field, or HDF, we can see a very small series of space and observations by the Hubble Space Telescope itself. It shows hundreds of galaxies. 5 billion light years out is the cosmic web, where billions and billions of galaxies are estimated to reside. And finally, 200 million light years out is the cosmic microwave background radiation afterglow, is what we believe that started us, the only thing estimated to be left of the Big Bang. That is our universe. What is beyond this? Other universes? Immeasurable heavens? We have discovered less than 0.1% and have found no other life. Are we all alone in this life? Or are we in fact not alone? Either thought is terrifying. For now, all we know is that all injustices, political and religious existence theories or truths, all loves, sorrows, hopes and dreams, extinct species like the dinosaurs, and species yet to come, all pasts, presents, futures, thoughts, and actions only exist on our small and insignificant planet alone. This sort of scale, you truly start to think about what truly matters to you, what doesn't matter anymore, and what never did. What do you think? Number 9. Rogue planets. They are the loners of the universe, lost forever in space without a star to orbit. When planets form, they react with each other gravitationally, and it's entirely possible that when our own solar system formed, planets were actually kicked out into interstellar space. There could be as many as 200 billion rogue planets in our galaxy. That's as many rogue planets as there are stars in the sky, and one of them could be heading our way right now as you're watching this video. A collision with another planet sounds unlikely. Could this really happen? As a matter of fact, it already has. 4.5 million years ago, a young planet about the size of Mars collided with Earth over 25,000 miles per hour, 12 times the speed of a bullet. The impact destroyed the smaller planet. Earth survived, but barely. Afterwards, the entire surface of Earth was liquefied. Nothing but rock, lava, and fire was left everywhere. A true vision of absolute hell. The Earth at that time had only an atmosphere of molten rock. Debris that was blasted out 20,000 miles per hour began to orbit the Earth. Gravity began to bring the debris together, and the result was our moon. Number 8. Space debris. Sooner or later, human civilization must confront the very real asteroid and comet collision hazard that exists within space, or we will become extinct. On June 14, 2002, it was just another busy workday, with all of the close calls and near misses that people all over the world have come to accept as the normal level of risk in everyday life. But on that day, behind the sun, what no one saw coming and what no telescope could see behind the blinding light, was an asteroid big enough to destroy an entire city. From behind the sun, asteroid 2002 MN came hurtling towards Earth, but it missed less than 1/3 of the distance to Earth that the moon is. Nobody saw it pass either until 3 days later, when it emerged from Earth's shadow into the night sky, going away. Though it is rare, it is very possible. The craters on our moon are evidence of asteroids, comets, and general debris hazards that do exist for us today. Billions of rocky fragments, building blocks of a planet that never quite came together when the solar system was formed, are out there everywhere, ranging in sizes from rocks to pebbles to boulders, and some the size of Mount Everest. The reason as to why we haven't had any truly devastating catastrophes with asteroids within the past few million years is mostly because of Jupiter. Occasionally, Jupiter's enormous gravity draws an asteroid off course, causing it to crash into another asteroid and be destroyed, or to veer away into new orbits. It was no secret that a giant rock smashing into Earth was what wiped out the dinosaurs, and that particular rock was estimated to only be 6 miles wide. Number 7. The sounds of space. It's a common misconception that there is no sound in space. Although space is a virtual vacuum, this does not mean that sound does not exist there. Sound does exist as electromagnetic vibrations. Through specially designed instruments such as the NASA Voyager, InGen 1, IC-1, and Hawkeye space probes, we have used plasma wave antennas to record vibrations all within the ranges of human hearing. Now I'm going to show you the sounds of our sun, as well as all of the planets within our solar system, and I really would like some input on what you guys think, especially about Venus and Saturn. Take a listen. Number 6. The supervoid. In 2004, astronomers discovered an empty section of space within the southern area of the galactic hemisphere where our Milky Way solar system and the Andromeda solar system reside, and that empty space is missing around 10,000 galaxies. Nicknamed the cold spot, this area is 1.8 billion light-years across, and it is the largest known structure ever discovered in the universe. But scientists are baffled about what it is and why it's so barren. It sits in a region of space which is much colder than other parts of the universe, and although it is not a vacuum, it seems to have around 20% less matter than other regions. Although the Big Bang theory allows for areas that are cooler and hotter, the size of the void does not fit with predicted models. Simply put, it is too big to exist. In this constellation, you can see superclusters of galaxies. The dark blue symbolizes areas that are more empty than others and much colder. The supervoid resides in the bottom right. The latest study of the cold spot suggests that it may be draining energy from light traveling through, which is why the area around it is so cold. In late 2007, it was argued by many scientists that this supervoid could be due to a cosmic texture, a remnant of a phase transition, which is known to be transitions between solid, liquid, and gaseous states of matter. The thing is, though, they believe it's a remnant of phase transitions that took place not any time recently, but from the very earliest stages of the universe. Number 5. The multiverse. When the ancients looked into the night sky, they believed that the heavens revolved around the earth and mankind.
It's amazing, huh?
There's a lot to process already.
Yeah.
Yeah.
And what's tripping me out right now is that the Earth probably wouldn't even be here if it wasn't for Jupiter, because like a lot of those giant gassy planets, like say another star out there, and they don't have that many rocky planets, but they do have these big gas planets that come like really close to the star, and sometimes those giant gassy planets are like the distance. Mercury is our closest planet to the sun, right? But these gas planets are even closer than that sometimes. So they move from far out and move towards the sun. And I think Jupiter was bringing so much debris with it as it was moving towards the sun. That's how all these inner planets, because they say it was probably like, we have 4 inner planets now: Mercury, Venus, Earth, and Mars. But it was supposed to have been something like 30 of them out there. But Jupiter comes in and pushes all these other things out the way, sending them out of the solar system and whatnot. And Jupiter would have kept going closer to the sun if it wasn't for Saturn. Saturn came into the picture, another gas giant, and slowed Jupiter down and even pulled Jupiter back a little bit to make Jupiter come away from the middle of the solar system. So everything from between Mars and Jupiter is that asteroid belt right there of all that debris. You see all those asteroids right there? So that's between Mars and Jupiter. And Jupiter, once it slowed down and started backing up, all that debris came in, and I guess all those planets start colliding with each other or whatever. And it's supposed to have been a planet called Thea, which actually didn't straight on hit the Earth, but kind of like grazed the Earth and made our moon and whatever. And it's just incredible that we probably would not exist as a planet if Jupiter would have kept on its course to move closer to the sun, like most other gas giants move towards their sun.
But then do you think that the Jupiter would have been destroyed if it would have moved close to the sun? Because
it probably wouldn't, because there's a lot of planets out there that circle their sun and they're not destroyed. So Jupiter just would have went on its course until it got close enough to orbit
be in alignment.
Yeah, to be in alignment.
Okay.
But then Saturn came in and just...
And that's why I was asking, because you were saying, like, you know, Jupiter was full throttle and then Saturn
Yeah.
came and had that balance
Yeah.
in its pull.
Slowed it down because the planets work on each other.
Right.
They mess with each other's gravitational pull. Yeah,
Mm-hmm.
they mess with each other, and
And
Jupiter
that's what
said,
allows them to move through space too, is their
yeah,
gravitational pull.
yeah, because they always
That's a
twisted
trip,
and
boy.
that's the same thing
That's
with
a
our
trip,
sun.
boy.
They think our sun is a rare sun too because most suns have a twin. It's usually two. That's the normal thing in the galaxy is two stars working together, but ours only has one. So a lot of scientists are wondering, did our second sun probably get kicked out of the area, or why we only have one sun compared to some other places?
Now, do other galaxies have a moon or moons as well?
Oh yeah, the other galaxy has moons, tons of planets, tons of asteroids, all that stuff.
But then, okay, so if we, let's say our sun did have two suns, excuse me, there were twin suns, how do you think we'd exist then? Still,
I think we would still exist.
because you know, in like number 10, they was saying that they go, you know, excuse me, scientists went further and further out in the galaxy with that camera, and they don't see any other life forms. They see the gases and they see the other.
I think things would have lived, and like in our existence right now on Earth is like a millisecond. We like humans as we're constructed now probably only been around for, they say, maybe over 200,000 years as we are built as humans now, and you know, like 90% of all the things that ever lived on this planet is dead already. So most things are going to die out. So humans are going to eventually die out sooner or later in some other form is going to end up taking over. But I think we would have still probably been here, probably maybe looked a little different or something maybe. But we probably would have still been here. There would have still been time for atoms and stuff to come together to make single cell organisms and then more complex organisms, because that's how stars work. A lot of those big giant stars, when they go into supernova, because they're really running on hydrogen and helium. But then once the hydrogen runs out, then it goes to the helium, then it goes to the next element, then it goes to the next element until it gets to iron. Once it gets to iron, gravity starts really sucking in, and then the stars just explode and start making more complex stuff like gold and platinum, and we're part of stars exploding. That's what we're part of. Every time a star explodes, new heavier elements are made, and it just keeps going, keeps going. So it's probably the same thing with us. We're going to advance to a certain point to where, you know, next thing is going to have to come up when we die out. Next thing's just going to have to come up.
And you know what? I do feel like there is life out there. Maybe scientists are looking for life in the way that they know it.
Like we
like
are.
right,
Yeah.
like they're looking for limbs. They're looking for maybe like a mouth, eyes.
Yeah.
And maybe it's not even like that. Maybe it's like
Totally
it's
different.
a plant, or it's in liquid form, or it's in like a grain, but it's still living. You just gotta like look beyond what
it looks
you're
like.
used to seeing.
Yeah.
Right.
Because most things on this planet have eyes, mouth. Most things on this
Limbs
planet,
to crawl, right.
Even I don't care if you're an ant or a flea. You got legs, arms, eyes to see.
Right.
So that's something
plants,
something I think that's probably natural to this planet.
right.
That all creatures have these things.
Right. Because it could even be like maybe like I know sci-fi, watching sci-fi. Like there's in the air, there's like the invisible like grains and microscopic.
Yeah.
Right.
Yeah.
And so maybe like if they can use something like how they use machines now to go out and like like how they did with the sound, that was a machine. How you go to get those pictures of planets, that was a machine. Maybe come up with a machine that can pull those cultures together, pull those microscopic
things together.
and then it may create like a being or something visual
Yeah.
that we can see. I keep in my mind, I'm envisioning like I'm doing this, like I'm envisioning like wind coming together, or like you know how a hurricane starts to twist, how it just pulls things. That's how I'm envisioning it.
And hopefully they go into that in the rest of here, because I've been like watching stuff, and they were saying out like how our solar system formed, about how our sun turned on and it's spinning and whatever, and then Jupiter starts to form and it's sucking up all this debris and dust and all this other stuff. Then other planets start forming. So I hope they go into that in this here.
Right.
It'll be good.
Troy, do you know how they come up with these names? Like what blows my mind is like star. Where does star come from? When like
Earth come
it
from?
looks like a big fireball. I would think you'd call it like fireball or something like
Yeah.
not star.
Right.
But I was just wondering. I was
I don't
wondering
know.
too. Maybe they were like last names of scientists who found planets or found because I know with medicine a lot of times it's like the person's last name, or they put
The discoverer, yeah.
right.
So I think, if I'm not mistaken, Earth means dirt. The word Earth means dirt. So,
All right, well, we'll look it up.
yeah.
Yeah.
We'll let y'all know what we find.
You ready to continue?
Yeah.
Yep, let's do it.
All right.
Space is beautiful, though, I must say.